this.
Hmm.
All right. Oh, I should share my screen too. Where's my screen share? Share screen. All right. Can everyone see? Okay. Can everyone see?
Yes.
Okay. All right.
So it's so confusing when you start screen sharing, then on Mac, Zoom goes in full screen mode, and then it hides all the buttons for unmuting. So it's,
Oh, does it really? Interesting.
or just me, I don't know.
No,
Yeah,
it
my
doesn't.
Mac doesn't do it, but
It does it for me as well.
does it really?
Yeah.
Yeah, it goes to full, but I still have the mute button on the lower side.
Interesting. Oh, when I screen share, you mean it hides all that stuff? Oh, interesting. Okay. Yeah, maybe. Okay. Let's see. We started working on the descriptions last week. So I definitely want to finish that. We had made our way down to
Well, the big sticking point was algorithm properties. You did defer to Basil for that one because we talked
algorithm
about,
properties.
yeah, we hammered out a description, but we were worried that the enumeration wasn't inclusive of a lot of the descriptions we found, and also from our experiences in crypto, did not match the wide range of things people might want to fill in there.
Right. Yeah, okay, that's right. I left it to do right here because we need to provide descriptions of each one of these things. And they don't have to be long. They just need to be like one, maybe two sentences, but one sentence is fine. Is that something that we want to do here as a group, or is that something that one of us
I think that's a homework piece for somebody more well versed in this. But I think the concern is that the generalized descriptions, and this was my experience as well, that these basically describes different primitives that you can trust. It's kind of like mini provenance of things in the realm of cryptography that people use to create new algorithms or drive new protocols or whatever they might be. So yeah. I think that we're hoping Basil would take this as a homework assignment. That was the hope.
So what's the idea to have describe that all in the description?
Well, the description, I think I was happy with the description, but it lists a bunch of things that are not included. Our enum is rather small compared to the realm of what we saw described through various AI and through various descriptions. And we don't know, and like I said, like basic things like referencing current ciphers, encoding mechanisms, that if you reuse things, basically if you reuse things that are well known in the crypto space, algorithms and things like that, those are unknown, and other seems to be too broad. Like things describe that the common descriptions are unifiedly see we build on RSA, we build on these ciphers or the ECB, or we build on these basic blocks, these basic things to drive new algorithms. So
yeah, these are the I mean the primitives is basically it's like a category, right? What the algorithm falls in. So it's maybe not not the building block for an algorithm, but more like the category of what an algorithm falls in. So that at the end, the goal should be that we also have other, right? So, but most of the algorithms fall in this category, right? So RSA is a bit of a special case because it can be used as a signature and as a PKE, public key encryption scheme. And but yeah,
If that's the
other
case,
ones.
do we need to make this an array?
No, it's no, it's just one algorithm is one primitive. So
Okay.
no.
Okay.
Right, but yeah, I can. If you added something there, I can review that.
Okay. Yeah, I'm gonna just go ahead and put your name right here so you kind of know. And then I can just send you this in Slack as well.
Mhm.
So you just so you can just, you know, if you want to just contribute back in Slack, that's totally fine.
Yeah.
I still have to check this in. Okay, so homework for Basel for the enums for the primitive.
Yeah, so maybe I think maybe if there's a better description for the property itself, for the field, if it really is a classification or categorization, that would make more sense.
Mhm.
Oh, all right. You want to read through this? Low-level cryptographic algorithm that is used as a basic building block for higher-level cryptographic function. Is that first part correct?
Yeah, maybe it could be rephrased slightly. Not sure yet exactly how to, but it's the primitive isn't an algorithm itself, right? It's more I mean, keep low level primitive, but that's reusing the word again,
Yeah.
right?
Well,
Low,
could we call it a low-level cryptographic function? I mean, in a mathematical sense, it's not necessarily a function, but
I think that what Basil said, like it is more like a classification
yeah,
than anything.
category of.
But
okay.
then if that's true, that begs the question of, do we want to really have primitives described? So like the building blocks. So it's about, it goes back to what I said last week about trust. You know, if here's this algorithm I'm not familiar with, but if I tell you it's built on these primitives that are well-known primitives, then I trust it more, or I understand how it was constructed. Right.
Yeah, it doesn't say anything about. It doesn't say too much about the construction, right? Because I mean, the signature can be constructed with lattices or with multivariate cryptography or with RSA, right? So wouldn't say
Well,
that
RSA says a lot, though. So I mean that the common definitions for primitives that we found examples like we included at the end of that description. So, and like I said, you know, if when I created a new protocol for, you know, Blu-ray disc stream networking, it was built on well-known primitives, AES ciphers, and electronic code books, and you know, SHAs and things. So those are the
Yeah.
primitives people are looking for, right?
Yeah,
So,
it's like usually I mean if you have a protocol, right? Like TLS works with you need a signature scheme for TLS for authentication, for example, right? So that's the primitive.
yeah,
you're looking
that is
for, and
exactly.
then so that's basically this description of what is needed in a protocol, and then you can plug in certain algorithms that fall in this category, right?
Right.
Like, yeah, I mean, you need a block cipher as well, right? Then you
So
can
I
use
get
AES, or you need to use a hash function, then you use SHA-2, and you need to, yeah. So that's
so what I'm seeing from the enum and with your commentary is that indeed the intent was to have a classification saying this algorithm is this class of algorithm.
Yeah.
And then maybe primitive, does primitive deserve to be another field, a different field, with a different description?
Yeah, these are usually, I mean, it's called primitive. It's like cryptographic primitive. So that's, I mean, synonymous for category. It's probably not.
So it sounds to me like the use of primitive is a little bit different than the primitive used in like programming languages, for example.
Yeah. Well, it'd be like algorithms. Like you took an algorithm course, so you would base your primitives, you know, be like this type of method or this well-known pattern or whatever. These are, you reference well-known
Yeah, I think
algorithmic primitives that are well-known in this field, basically, are well
I mean,
established.
yeah, on a let's say if you look at the let's say software architecture perspective, the primitive basically tells you what API this algorithm will have, right?
Mm.
So, I mean,
Okay.
if I say dilithium, yeah, maybe unclear what API it has, right? But if I say it's a signature scheme, then I see, oh yeah, it has keygen, signing, open, verify, and so on. I think that's useful then for certain policies, probably, right? So because
Okay.
Like,
So
yeah,
what
to-
I'm
yeah,
hearing is
yeah,
that
to- yeah,
the
to- that see, like I said, from my perspective, if you know the primitives to me, at least when I was reading the definitions last week that we found through the AI lookups that we did, it basically it speaks to trust. Well, when I see an algorithm, Spooty, Fluty, whatever, I don't know, some new one, at least I know it's built on things I'm familiar with. So
yeah, I altered the description just to I shortened it. So low-level cryptographic building block used in higher-level cryptographic functions. So I'm not calling it a classification or an algorithm or anything like that.
cool.
Is that description is that part of the sentence okay?
Yeah. I think the concern is that, you know, the enum now looks like, as it makes sense the way Battle described it, the enum looks like a classification, but it doesn't look like like a list of primitives.
Right. Although the term is used in cryptography, I want to stick to the use of that term. That's basically the same approach we did with ML. Even though I didn't agree with some of the word choices, it was what the ML folks used. Okay, second part of the sentence. Primitives can be used to construct algorithms used for encryption, AES, digital signatures, and pseudorandom number generators. True statement?
Yeah, these are examples, right? So this
Yeah.
would need to be yeah, encryption, right?
Encryption, digital signatures, and
there, I mean, encryption, there is you have in the
right.
list, in the enum, we have block cipher, right? And
Right.
street cipher, which are two primitives for encryption, right?
Yep.
And
I just want to give a few examples
yeah.
so people could associate what a primitive actually is used to create. And then what we need here, and you can just give it to me, Basil, but what we need here is just a description of each one of these things. This is beyond, I mean, I know what most of these are, but I don't have the expertise to kind of create a description that's going to be accurate.
Yeah. Yeah, that's what I can have a look at and send you some text for that.
Okay. All right. Variant. The variant of a, yeah. What
Yeah.
is the variant?
Yeah, that's something actually that's what I mentioned in the on Slack, that there is a PR that removes the variant and adds another field where we probably also have to discuss the description, but
Weren't you refactoring this part?
sorry?
I thought you were. What part were you? What part of the spec were you working on with the PR? I can't remember. Was it this?
Yeah, it's
Or was
it removes, or let's say it renames variant to
Oh,
parameter set identifier.
okay. All right. So I don't want to. I don't want to work on something if you're going to submit a change to alter it, because otherwise you'll have a merge conflict.
Yeah.
But if you could, I know you're working on that PR, right? Is that coming this week or
Yeah, it's
next
I
week?
just did it this
Oh, you just
morning.
did it? Oh, okay.
Paste.
Yeah, let's make sure that description is nice and crisp.
Pasted the link.
In the chat? Okay. Okay, so variant changes to parameter self-identifier. Oh, you added a good description too. An identifier for the parameter for the parameter set of a cryptographic crypto algorithm. Examples in two. Oh, I see. Okay.
So
All
the
right. That makes sense.
yeah, the idea there was one use case basically. Gero, he had basically wanted. I mean, there's policies that says, okay, you should use AES with key length 128-bit or longer, right?
Yep.
So okay, we could add a property for key length, right? But we thought, I mean, what's behind that is basically you want to specify what's the parameter set used, and in the AES case, right, it's AES is identified by the key length, which can be 28, 192, or 256.
Yep.
But in SHA-2 or SHA-256, it's not a key length, but it's the digest length.
Right.
Have certain values. Shake as well. There, let's say shake is a kind of a hash function. And the 128 in its name just identifies its maximum security level in bits. So it's yet another unit. And then there are some. So we just had one short discussion about, yeah, what should it then be an integer field, right? Because so far we had lengths, right? Key length, digest length, but it's not always the parameter set identifier it's an integer. Like in this example here, SLHDSA, this is one of the quantum safe signature schemes that NIST standardizes. There, the parameter sets are just, for example, called SHA-2 128S,
Right.
which identifies the hash function that it uses inside for as a hash-based signature scheme. So that's why we have it here as a string. So, but it should be flexible enough, right, to accommodate any parameter set identifier.
So, question for you, just general noob question, I guess. This is actually the first time I'm actually hearing of this algorithm. Will if I run a file through like a SHA-2 128 hash function, and will that produce the same hexadecimal output as a 128S, or will the output be different?
I mean, it's used as part of a signature scheme, so a hash-based signature scheme, which works internally with hash functions. And so yes, there are different variants there. I think one is called SHA-2 128S, and another one is SHA-2 256S. And they will differ in the signature output that you get, and in the signature length, and the security level, and the performance characteristics, and so on. So so this will differ. Yeah.
Okay, that's very good to know. Could you paste a where can I get a list of these algorithms? You said NIST, right? This is
Yeah.
all the quantum safe.
Yeah, they have they are called so far.
It's in FIPS.
This is FIPS 205 draft
Yeah.
version. So there's also FIPS 203, which was Kyber. There's FIPS
Right.
204, which is dilithium, and then there is this FIPS 205, which is formerly called Sphinx Plus.
Okay.
They
All right. I'll
they will
take a
release
look at
another
that.
one next year.
Oh, really? Okay. Do we have an update on speaking of US government type stuff, do we have an update on the work with MITRE?
Not really. There was not any call yet. The next one is after Thanksgiving.
Okay. All right. Very good. Okay, so this makes sense why the name was changed, and it's, I guess it's general use. So this makes a lot of sense. So I'll go ahead and accept that PR as is. I think the description was good as well. Okay.
Okay, thank you.
Yep. Thank you, Basil. Basil. Let's see. That should come in. Yes, it does. Okay. Good, good, good. Okay, I'm just gonna examples. We've been trying to spell out crypto to cryptographic in most cases. I know what you mean, but
Yeah, but
this is
that's a
going to
good
be used for more formal documentation. So, parameter set identifier. Okay. Okay, last week we had discussed curves, and the concern, because I was working on externalizing, and I've actually put a pause on this, externalizing a lot of the enums that we had previously talked about. And the concern was that we don't necessarily have an authoritative list, especially one in a machine readable format that we could use as a reference for how to name all of these different curves and where and when to get the list. This seems to me like it might be a little unmanageable unless we are staying on top of it all the time and we have an authoritative source in a machine readable format. Thoughts?
Yeah, I mean the list here. It's. I saw that Nicholas, you pasted the link on Slack.
Anytime an enum becomes this large, I become worried.
Yeah,
Yeah,
I mean,
we were going to externalize it similar to how we did SPDX license IDs. But with the SPDX license IDs, I have an authoritative source, right? The SPDX team with their lawyers, they create, a standard for the IDs, and then they publish the IDs in a machine readable format where others can consume, which is what we do. My concern is that I don't have an authoritative source, nor do I have a machine readable format. I've got the website that Nicholas shared last week, I think it was, right? And there's really no way for us to, I mean, without doing some really odd things, there's no way for us to really do like an enum or a string. I mean, technically you can, but it gets kind of messy.
Yeah. Good question.
So the concern there is that that these might not be unique, or that these might change, and we have to be the authoritative or
Yes.
source with identifier.
Yes.
Yes.
Both.
So
Both.
right, yeah. Yeah, so if it's the only machine readable source, then we have to maintain it, kind of.
Right.
Yeah.
Maybe then we should just make it a string, and I don't know if that is something that is aligned with the CycloneDX guidance, but we can add a link to this other site.
Can I ask a dumb question? So are there, I guess the question is about, maintenance and growth. And it looks like there's tons of variants. Are there classifications where they all fall under a certain type of, curve type or curve classification? Where we could break it out, like we could have somebody describe a enum of a classification and then have a free form field to describe the specific, variant of it. I don't know, just brainstorming, just looking at these things. Because I've only looked at like two of these curves described elsewhere, and this list is overwhelming. But it seems to be they're like named classifications potentially. If that could be broken out in enum, I don't know. Does that have any value? The question is, what value does it have then? If I know I use a certain curve classification type or algorithm type, without the specifics.
I think the main motivation is that these are, if you have a policy that says we have a list of curves, right, that you could easily match in a schema. I think that's the main use of this list.
So I guess goes like Steve said, goes back to what canonical source, basically will say this is the official name for this thing. I guess that's what it always goes back to,
Yeah.
Where,
if you look at the source that we took for it, the names, it's basically they are standardized by different standardization bodies, and they give the name of these curves.
Well, that's what we should be referencing then. We should just say, here's a free form field and point to the standardization body if there is, and if they publish, if these are true, use the word standard. If these are truly standards, we point to that standard, right?
Yeah.
Are they really standards, or is that a loose term we used? Is it really a standard?
If we made this a string and not if we remove the enum, what impact would this have on policy evaluation? Because that's a primary IBM use case, right? Or the primary use case you're envisioning?
Yeah, if the value is correct, it wouldn't be any problem for us to validate it against policies. The problem is if you have a string field, then the user can, append the space, and the policy may work when we use contain, but may not if there's like a hard equal match. So yeah, I think we have to then just do a little bit of sanitization and hope that the string that the user puts in is valid.
Well, that's what I was trying to get back to. I don't know, what policies I would write. The question that goes back to categories. I guess policies can be very specific, but I'm thinking like regex. It's like if I'm using, the question is am I satisfied if it's using a certain curve derivation method, and then I can just have a classification as I'm okay with that, or I understand what's being used, or am I going to be very specific and say it has to be exact? These are actually identifiers, and I will reject the software because it doesn't have a specific curve identifier. Anyway.
Yeah, I think it will be more about identifiers. It's always like one curve identifies, for example, the security level, which we have anyway in a separate property. And then, yes, there are curve categories, right? Some are over prime fields, some are over binary fields, some there are different kinds of curves, like Weierstrass curves, Montgomery curves, Edwards curves, right? Which, yeah, that's all kind of things that you could actually add as a property if you would like, but don't think that there is a main use case actually to have all these specifications there. And I expect that the most frequent use case is to really match against the name of the curve.
Another option
Wait,
might
do we
be.
here, just sorry, Steve. I mean, can we get a enumerated list of the standards bodies? Like like for ECC, there's a national standards body at NIST that manages, but for other curve types, can we get a list of, for each of these curve types, can we get a list of enumerated standards bodies so we can point to them?
Yeah, I mean, there are different standard bodies that.
Yeah, that's what I'm saying for each. Looks like different curve types have different
ASMI
standards bodies.
X962, 963, there's ANSI.
Yeah, I mean, can we get that in writing? Could you put together a list of those things? I mean, I think having that might be meaningful at some point. Maybe not within the schema itself, but anyway.
So this is the website that Nicholas shared with me. I think it was last week. That basically this list of curves was obtained from.
A Gibson fan, I see.
Yes, so it is by an individual named Jan. Yeah, I'm gonna butcher that name. I don't know, but it's from an
But
individual.
yeah, they've divided up by different standards or different things. So they have NIST and Oakley and
Right. One option is, I don't, first of all, does anybody know this individual? Okay. Then one thing that we might want to do is kind of reach out. And since there isn't an authoritative source for the enums, maybe as an option, we could become one and have that repo possibly under TC54 and have a bunch of folks actually contribute to that as a separate, we could have a separate task group that specifically defines what that list is. And
that sounds great. I mean, the question is, I think that with anything, you need somebody to be the consistent champion for it. You can't be
yes,
just like, I dumped my information on you, Steve, then they take off. Then Steve's holding the bag for eternity, right?
exactly. So I would recommend if someone can, like Basil and Nicholas, if you can reach out to this individual and possibly even maybe some of the contributors and see if they're interested in making this an actual authoritative source of curves, because I think I really want to keep, I like to keep the strict the strong typing that the schema provides, because it's really going to help with policy evaluation. I think this is going to be used a lot. And a string field, there's a high probability that the tools would just put garbage in there and get it wrong. But I don't want the CycloneDX spec itself to be the authoritative source. We need something else that is the authoritative source. We can create that authoritative source, and we can do it outside of Cyclone as kind of another option, and we can do it under TC54.
Sounds great.
Okay. All right, so we'll revisit curve, although we do have to work on the description. Fun.
Well,
who wants to take a stab
as
at
long as we pulled up the repos, what does their README say?
what is a curve?
Yeah, exactly. What I mean, we should be in the first paragraph of that GitHub repo.
Let's see. Let me go down. No. It doesn't tell you what a curve is. It assumes you know what it is.
Gotcha.
Yeah. I guess if you're reading this, you're probably already a cryptographer or somebody, truly embedded in
Can I ask a
the
really dumb
space.
question though? Because I've seen some really interesting curves. So, but these are not all elliptic curves, are they anymore? So they can actually be very strange ones. And actually, it looks like it looks like some of them are actually combinations of ellipses. So it's actually interesting. Is that? I mean, I'm asking my own edification. Oh well.
Yeah, I don't know the answer to that.
Because I'm not finding a good definition, but when I'm searching, I'm seeing some interesting graphs of what the curves look like, and they look like combinatorial functions. Or anyways,
Of elliptic curves.
I've seen one where it looks like three elliptic curves are kind of strung together like a mini sine wave. So it's actually interesting.
Yeah, there are different types of elliptic curves that have different graphs.
The README does say this page contains a list of standardized elliptic curves. So I'm assuming all those curves are elliptic curves. I mean,
Yeah,
I
it
don't
looks
know
like
of
that
another
even
curve type, but
yeah, I think that in general, I'm just finding elliptic curves. So I was wondering if we could use the NIST definition. That's why I asked the question if all these elliptic curves or not. But it looks like even the ones I'm seeing graphically, they look like they're elliptic curves that are strung together in some phase. So
right.
Which one do you look at then? Just
I closed the site, but I was looking at images from Google, and I saw I saw some plots of some of the curves. So, anyways.
yeah, I mean yeah. But yes, I mean this list is a list of, I think that's an accurate definition. It's a list of standardized elliptic curves.
Right. Now, the thing that confuses me a little bit is that the site is under this one individual, but yet the logo on the site refers to the Center for Research on Cryptography and Security, or CROCS.
Huh. I mean, it seems like when you scroll to his blog that he attends and, had some keynotes there on a conference related to that. No, I don't see it wrong.
CROCS Industrial Partners, Red Hat, Oracle. Okay.
Right.
So maybe the CROCS folks can be the authoritative source. I just don't know if they have their own like dedicated GitHub repository, because I don't want to refer to like somebody's personal one. Oh yeah, they have their own GitHub organization. This is the I'm pasting the URL in the chat. That's the organization. Is this a nonprofit then, or a university thing, or what is this?
The description says at least that it's started as a lab
right.
of Masaryk University.
Yeah. Okay.
like a university lab.
Interesting. Okay. Can someone reach out to the Crocs folks and, you know, um, possibly, you know, invite them to a next meeting type of thing? Would that be possible?
Sure. Just question, Basil. I mean, I can do it, but if they have like detailed question about curves, I'm definitely not in the position to answer
Yeah,
anything.
if you have some time just to ping them and
Okay.
can take me in CC or.
Okay, so I just ping them and ask them if they want to join the call, and then we can speak details here.
Yeah.
Or okay.
Yeah, give them some background and, you know, that sort of thing. But yeah, that would be great. Okay. Because if they can be a primary contributor to this on an ongoing basis, that would be ideal. Okay. Do we want to take a stab at the description? Excuse me, description for what a curve is?
I've been looking, but nothing that is something that's not self-referential.
A part of a circle.
Yeah. This is the best one that I was going to work. I gave up, but this is the one. Let me paste in the chat the one I was going to build on.
Yeah.
Maybe it won't cut and paste. Hold on a second.
How long is the wait list? Does anybody know how long the wait list for ChatGPT 4 is?
I don't know.
Yeah.
Yeah, I'm just gonna copy it in. I'm just gonna point to something to the URL. But look at the first. I think things are applicable in the first section, the first 3 paragraphs. That something could be derived from that. Anyway.
Family of cryptographic crypto systems.
But I like the I was trying to play on the stuff, you know, use the first paragraph as the basis without being self-referential, and
Right.
then borrow from what was in the 3rd paragraph there, which talks about, you know, its benefits, basically. Like, so it's basically, you know, this is what was meaningful to me for a description, but it's used for signatures, you know, what's uses are basically for provides very fast key generation, fast key agreement. So I don't know, we want to describe the field, but anyways.
Yeah.
But anyways, I mean, it could be referential for now, I guess. I don't.
Yeah. Yeah, actually, yeah. And we can give a description of elliptic curve cryptography, what it is, right? But yeah. But yeah, right now the description is a bit it's a bit vague, right? So
They're all vague. Everything I found is vague. Because I guess the proof is in the algorithm. That's the problem. I think that just describing, I mean, I was trying to get like describing why you use elliptic, you know, I don't know. I guess it's just assumed in the field. I mean, but I think the interesting point that I hear that I didn't see the other one, it basically was on the what was in the first paragraph, which is based on algebraic structures, elliptic curve finite fields, and the difficulty of the elliptic curve discrete logarithm problem. So I mean, as a definition of what it is. The question is, all we're describing here is that these are algorithms. Again, it comes back to canonical source.
Yeah. I mean, the curve itself is not really an algorithm per se, right?
No,
What
it's
type
the curve
thing?
that algorithms are based off of. Yeah.
Yeah. I mean, I also like maybe in the third section about curves and key length description on the link that you sent, Matt.
Oh, okay.
Like ECC crypto algorithms can use different underlying elliptic curves. Different curves provide different level of security, different performance.
Oh yeah, yeah, I like that. I like that. That first paragraph there, I think, is absolutely the basis for the description here. Yeah. I'm only dealing with one screen today, so I'm trying to look at the paragraph and see if I can hammer something out.
So do we want to take that paragraph that we were just talking about, slightly modify it and use that for the description? Is that what we're talking about?
I'm trying to hammer something out, Steve.
Okay, fair.
Yeah. Just paste the section
Yeah.
that I think is might be good for as a basis.
One thing that we don't want to do, this seems to be a .com, but yeah, we definitely don't want to plagiarize from this. Yeah, because this is from a book. This book is not finished. Oh, okay. Practical cryptography for developers. Interesting.
I'm shortening it, which is a good thing.
Okay.
All right. Sending, and feel free to carve it up.
I'm good with that. Although, is it an algorithm?
Yeah. Maybe definition instead of algorithm.
Yeah, yeah. Yeah. Thank you for that.
Otherwise, I think it's good.
Yeah, I think it's good too. Thanks, Matt.
Here.
Awesome. Okay. So Nicholas, I guess you've got homework to reach out to those folks. Is that what you're going to do? Okay, that's awesome. Thank you,
Yes.
thank you, thank you, thank you. Yeah, it is a long list. Okay. Okay, this also has a list of enums, which we'll need to define. Implementation level. What is the definition of this?
Yeah, I'm at a loss.
Yeah.
And if we have like 30 seconds before the meeting ends, I got a humorous story to convey to you, Steve.
Okay. I'll stop the recording in advance.
Yeah, please.
Yeah, maybe need some thoughts to find a bit more descriptive description.
Descriptive description. Okay.
Could you
Got it.
could you give a free form description in your head, just of what?
Yeah, sure. I mean, implementation level, it's yeah, basically the kind of implementation that you have of a certain algorithm, right? So you implement it as software, like software implementation that is commonly runs in unencrypted in RAM, right? Where you can, let's say, which has attack vectors are, yeah, other processes that can read secret data and so on. And second
Interesting.
kind
Okay.
of implementation level is like if you run it in encrypted RAM, right, where that becomes harder. So kind of a bit in like in a
Yeah. I'm with you. I understand. Yeah, I understand.
Then you have the trusted execution environment where you have very tight control to who can access, or yeah.
I would expect to see more about. I liked what you said at the end. If it can be referenced in, by field name about trusted the execution environment, if that could be instead of implementation level. So I don't know if those are implementation level are terminology used in the field of. I've never heard that before. But to me, in terms of we described saying trusted execution environment, that makes sense to me. That rings a bell in my mind, right? That resonates with me. If it maybe so, I don't know if it's possible to name the field about you know execution environment or something like that. I think that would be the field name, and if I were designing this as a lay person.
Yeah, I don't know if there is like a commonly used term. So implementation level, I think, is just something that we used more or less ad hoc. But maybe execution environment, maybe that's a good.
That feels good to me. So,
and then there is TE, like it's one kind of execution environment. Plain RAM, encrypted RAM, hardware.
What is software T? I've never heard of that before.
It's TEE. TEE stands for trusted.
Oh, that's trusted execution environment. It's an acronym.
So it's a software implementation.
I didn't know that. I was like thinking about T'ing command line functions together. Like, okay. Yeah.
So what do we want for a description of this?
Maybe the target and execution environment. So not trusted, but
right, because the other ones may not be.
And perhaps the enums, if they do have acronyms, they don't need to be camel cased like that necessarily. If it's RAM, it should be RAM capital. It should be TEE. So we know.
So you're saying like that?
And the T should be. I didn't know T was an acronym. TEE is T capital E, right?
Right. Okay. Let's see, what's the format for this again? So yeah, we only got a few minutes left. Would it be possible, Basil, to as additional homework to get us descriptions of each one of these?
So we're going to rename the actual field name to execution environment, or
well, I thought the cryptographers call it implementation level.
No, I don't think.
No, that's not a term I've heard before. No.
Okay, so this is not an industry term?
No.
Okay, well, if we rename it execution environment, then we need to this is going to be self-describing then too. We'll have to come up with a different description. We'll
It doesn't, no, I think description is still fine. We're just,
is that what we're doing?
yeah, that's what I would like to see. That's meaningful to me.
Okay. All right. I'll go ahead and get this checked in. Actually, yeah, I need to do one thing before I do that. Though.
So short story for everybody, not just
Let me
Steve.
stop.
So when we're developing Blu-ray disc encryption, there's